Now let's see the periodic trend of metallic character. So metallic character is a down left property. I'll take the pen again. This is a down left property. So let's see the periodic table again. And in the periodic table, you see this portion. This portion is very crucial. This portion. So this portion is actually dividing this periodic table into two halves. So this right hand side, these are called non-metals, whereas this left hand side, these atoms and elements, they are called metals. So here in this periodic table, these sky ones are metals, and these green ones are metalloids, and these yellow ones are non-metals. These middle elements, these elements which are separating these metals to non-metals, so they are having some property common to metals and some properties common to non-metals. That's why these are called metalloids, which is in between metal and non-metals. So if I will just say one more thing, that metalloids, these are the metalloids: boron, silicon, germanium, arsenic, antimony, tellurium, polonium. So people remember it as a stair step. So you get one step, again here one step. So as a stair step, we need to remember it. And in this stair step, I remember it as 1, 2, 2, 2 formula. That means when we are making the stair step, first we have one element, boron. Then in the next step, we take two elements, silicon and germanium. And in the next step, we take another two elements, arsenic and antimony. And again in the next step, we take tellurium and polonium. So these 1, 2, 2, 2, I remember for the metalloids. Now how do we define the metallic character? So the metallic character of an atom is estimated as the ability of losing electron and gaining positive charge. So if you have one element, maybe let's take magnesium or sodium, so these elements, they will try to lose the electrons. If they are more prone in losing the electrons and gaining the positive charge, that time we will say that they have higher metallic character. Whereas if you take this this right hand side element, these elements, they do not want to lose the electrons, whereas they want to gain the electrons, and gaining electron, they will gain negative charge. So that's why these are called non-metals. Now if you see the periodic table, so the metallic character increases in the down left property. This metallic character is the down left property. So along a period, if you go from left to right, the metallic character actually decreases. In the other word, if you go from right to left along period, the metallic character increases, and from top to bottom, if you go along the group from top to bottom, the metallic character increases. Now why so? We are going to see. Now let's first see along period. What are the factors that are affecting along period? So along period, principal quantum number is fixed. That means the number of orbits are fixed. The number of shells are fixed. Effective nuclear charge increases. Yeah, we have already seen as we are putting more and more protons in the nucleus. So the effective nuclear charge, the attraction of that attractive girl towards the boys, that is increasing, right? Now size gradually decreases. This also we have already seen. And the other factor is electron-electron repulsion also increases, but this is a minor factor. We are not going to consider this in this case. So for this, the electrostatic attraction of nucleus towards valence electron increases along the period, and the possibility of losing electrons decreases. Hence the metallic character decreases. So that means when we are going from left to right, let's take this from left to right along a period. So what are the things happening? The effective nuclear charge is increasing and the size is gradually decreasing. So now as the size is decreasing, the nucleus can attract more the electrons, the valence electrons, right? So now if the nucleus is attracting more and more to the valence electrons, now it will be difficult to take out electrons, and the atom will not try to lose electrons. So if it doesn't lose electrons, then the metallic character decreases. Okay. Now next, see along group. What are the factors that working along group? So if we go from top to bottom along a group, we can see the size of the atom increases. We have already seen that when we go from top to down, the number of orbit increases. As a result, the size of the atom also increases. Now I will show. Let's suppose in case of lithium, so this is the nucleus, and this is the first orbit, and this is the second orbit. Whereas if you take the sodium, in case of sodium, this will be the first orbit, this will be the second orbit, this will be the third orbit. Okay. So as we are going from top to bottom, the size of the atom increases, and the outermost valence electrons are placed far away from the nucleus and easier to take out. So the outermost electrons are here in the second shell, right? Whereas in case of sodium, the outermost electron is in the third shell. So it is very easy because it is now the distance is more from the nucleus to electron. So as the distance is more, now it is relatively easy to take out this electron from here to outside. So if we take out this electron, means it will be easier to remove the electrons. So that's why the metallic character increases along the group. So as we go from top to down along a group, the metallic character increases. Now one more factor we will see, that as the metallic character is defined as the tendency to lose electrons. So that's why these metals, which we call metals, these metals can easily lose electrons. And by losing electrons, the number of electron becomes less and the number of proton becomes more. For example, let's take sodium. In case of sodium, so first we have 11 protons and 11 electrons. So as we remove one electron, so that time we still have 11 protons, but now we have only 10 electrons. So this forms a unipositive charge. So this is called a cation. So sodium forms a cation because it is a metal. And generally these metals tend to form cation by losing electrons. Whereas in the right hand side of the periodic table we have non-metals. They actually tend to form anions. They try to take electrons because they have higher electroaffinity and electronegativity. That's why they tend to take the electrons, and by taking electrons, the number of electrons compared to the protons get increased and it becomes negatively charged and they form anions. So let's see the keynotes in the periodic trend of metallic character. So this is a down left property. We have already discussed that this is a down left property. And from left to right along a period, metallic character decreases. As we go from left to right along a period, the metallic character will decrease. And from top to down along a group, the metallic character increases. And non-metallic character goes exactly opposite to the metallic character. So from left to right along a period, as the metallic character decreases, the non-metallic character increases. Whereas from top to down along a group, as the metallic character increases, from top to down along a group, the non-metallic character decreases. So if someone asks you about non-metallic character, you just simply have to reverse the metallic character trend. Okay.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.